Okay. So I'm actually opening this here, but let us actually first look at uh, this presentation again. So just to recap, this is what it is, right? So we have in the traditional networking, this is what it is. So you have this is how today's world is. How the different continents in the world is connected. How the global fiber optic network, because the entire IT network is really running through this fiber optic network. As you can see, some continents are there are a lot of connections that are running, where there you can really see some very thick lining goes, that is basically between US and Europe. There are multiple point to point destinations, or even multiple point destinations that run across the Atlantic. I mean, it's far underground in the Atlantic Ocean. All these cables are running. So all these so you see, even the remotest parts of the planet, as an example, this is Greenland. Even Greenland also has a cable connected from Europe to Greenland. So so that much kind of coverage. Even there are Alaska also has some network. Even you see that some local network connection is there. And then all these fiber optic cable from Alaska also, it is running all over the world. So like that, and then it goes to Australia, it goes to New Zealand, it goes to Singapore, I mean, like South America, Africa, everything is connected. But maybe uh, the the amount of the thickness of the network is probably not that thick when it comes to South America or in between Africa or something. But lot of connections go to some really wherever IT is used heavily, that is Americas, Europe, and you also see some good amount of traffic going into Asia, China especially, right? Little bit in Australia, and quite a bit to India also right now, because right now in India also it is not that as thick as Europe or anything. But I think that there is a lot of fiber optic cable that runs to India also. So India probably may in future may have a lot more. But I think that's how all these world networks are connected. And like we covered this particular thing. Okay, so I have an office in New York, I have an office in Chennai, and how these two their networks are there, how they are connected. So you have this internet connection that is coming here. So you have three network layer, you have a core layer, aggregation layer, access layer. So servers are racked here in separate cabinets. In the top of each of the cabinet, they have a network switch to which the individual cables run. From there, the cables are connected to individual servers. So there are multiple traffic. So anytime a particular server has to really send some network data, then it has to really travel through all these hops. It has to travel through the top of the rack switch, then the aggregation layer, then the core layer, then goes to internet, then it will really hit a kind of a local hub here, and then we also it goes all the way, it goes to internet, and it hits here. So similarly, in Amazon also the same thing happens. Like we have tried last time, creating two servers in two different regions. So we are here, if we create a US server in US East, your ping response time, it was actually lesser, smaller. And when you really do it in a different say I am here in US and I create a server in India, and I try to ping that server from here, obviously it is going to be much more a bigger millisecond. So that latency is really going to be high when you really travel across the globe, to that subcontinent. So that's one thing that we covered. So when we are talking about AWS cloud also has multiple regions. So, and since we are talking about finally, how we are really trying to get all these things into that one particular network, we say that how this is all coming into the different some of the use cases also we have seen. You have the three-tier architecture layer, you have a data layer, app layer, web layer, how that is done, and also how people really create in companies various different subnets, for one subnet for each of the departments. These are all some of the network architecture schemes, correct? So the IP addressing, you have two different way of IPs. One is private IP and public IP. Those kind of things are there. And we also said, spoke about that CI DR classless interdomain routing. So that classless interdomain routing is the core concept of networking, because when you have network, they have two different ways of internet protocol. So one is your IPv4, which is what is traditionally used, and that is the actual use, in Amazon also. So this IPv4, it provides IP addresses which have 4 parts. So in each of these 4 parts, you also have certain logic that you also have say that what is my subnet mask. So with that subnet mask, you should be able to find out how much addresses that I will have. The subnet mask, if it is when we say subnet mask, each of the subnet is 8 bytes. It is all about how many bytes I want to mask. If I mask all 32 bytes, it is something like you get only 1 or 2 address or whatever it is. But if you mask less than 32, then as you start coming lower, then in that case, you start getting more IP addresses. So sometimes, it is difficult to remember. So there are websites there, where you can actually go and really check how much I will really get, the IP addresses. I think there are IP address guide is one website. So you go to this IP address guide. Here you can always give something like this. Say as an example, I give even 10.0. Okay, so I have to type it probably. Okay, so if I say 10.0.0.0/32, I say /32. It says that totally you get only one IP address, because like I said, 32 means all, you are completely masking everything. So in that case, you get only one IP address. Your first IP is 10.0.0.0 and last IP is also the same. Okay. So I think let me go back. Okay. See, the formula for this is a little bit interesting. That is what you can actually use this tool also to really validate that formula. What we will do, I'll just open it. Let's take this. Okay. Okay, so I'm going to write a new note. Okay, so you have an address block like this. So if I have /32, then it is like this. Okay, so the formula is like this. In mathematics we will say something like 2 to the power or something. For power, we put something like this, right? 2 to the power 0, that is equal to 1. So you get only one IP address. If you put 10.0.0.0/31, that this particular 0, how it is really done is 32 minus 32. That is what it is. So your mask, you have to really try to understand something like that only. So here 0, if I say 31, then how do I really do that? The same thing, 2, to the power, you say 32 minus 32 minus 31. That is 2 to the power 1, which is 2. So here it is something like 2 to the power 0, so it is 1. So this is how we need to calculate. So if it is something like, if I say 10.0.0.0 slash, say if I choose a number like 28, then it is 2 to the power 32 minus 28, which is 2 to the power 4, so which is 16. So this is how it calculates. So but we don't need to do all this kind of math. We can actually just go here 10.0.0. 0/31. So let's actually go here. 31 means it says 2 IP addresses. See, it says it starts with 0, it ends with 1. So similarly, if I say 28, it will say the same thing, 16 IP addresses. It is from 10.0.0 to 10.0.0.15. Okay, so typically the best way is you go 16, then in that case 16, which means that the last 2 digits, as you can really see, 10.0.0 is the starting. 16 means 2 bytes are masked. The first 2 bytes are masked. Okay, first 2 bytes remain constant. The remaining 2 bytes, you can really get the entire range. So it is from 0 to 255 of your this particular byte, and 0 to 255 from this particular byte. So you get 255 10.0.0 from 10.0.255.255. So you get nearly 65,536 IP addresses. Okay, so now internet has, there is a kind of an authority called IANA. This is called, what they call as IANA is the Internet Assigned Numbers Authority. So they are the authority that actually is a global authority that really says that how IP addresses are allocated across the globe. Okay, so they actually define one particular standard. What they say is, okay, the IANA guidelines on IP addressing. That is something that we need to really know, because that is going to be very critical. Okay, so what I am going to do, at the end of this particular diagram, let me write that. So IANA, so internet assigned number authority guidelines on IP addressing is this. So how they say IP addresses need to be assigned for private network. If it is a private network, like I said, a company within a company, or something like private IP block. For a private IP block, you have only 3 allowed ranges. One is 10.0. Or I would say 10. You say x.x.x, whatever it is. That is one range that is allowed. The other range is 172. Say again the same thing, x.x.x. The other that you have is 198.x. So these are the only 3 blocks that are allowed. This particular 10.x.x, this is for generally used for large enterprises. This 172.x.x is also similar. AWS uses this particular range. Okay. Then this is typically for home network. You will really find this 192 block, basically. Okay, so mostly if you really go to your home network and then just really say if config, you will really find an IP address somewhere here. So I'm just maximizing this. Okay, so if I go, if I go to the top, generally this is a long output. So if you go to the top, you will find your IP address. Where is it? Okay. You will find your IP address. INET is there. Yeah, see here 192.168.1.11. That is the IP address of this computer. Okay, so that is how home IP addresses are assigned from the router. The router is configured to give that kind of a thing. So that is how home network is configured. Okay, so this is the, so any IP address that does not belong to these three blocks, everything else is allowed set of public IP addresses. Other than this 10 dot range, 172 dot range, 198 dot range, everything else is allowed. Not 198, I think probably
192.
192, sorry, yes, 192. Okay, so 192. Okay, so this is all allowed. So everything else is public IP address only. So that public IP addresses only are allowed. So now, since with the AWS, VPC is the default. So when you create VPC, you can use either of these blocks. Typically, most of the time, people generally prefer, in companies, most of the administrators, they generally prefer to use 10 dot IP range. They mostly may not really go for 172 or 192. In some cases they may go, but mostly they will use the 10 dot IP range, 10 dot x dot x, that IP range only they will try to take it. Okay, so I will try to do a walkthrough on something like how your default VPC looks like. So if you go to your account and then just type VPC, then generally okay, I don't know like why. Okay, so you have a VPC, a dashboard like this comes. So in this dashboard, what happens when you create an account, there is a default VPC. So this default VPC gets created for every account. You go and really look at your default VPC. So the VPC, it says that available. You get some of the things. It has what they call as a route table. It has what they call as an access control list. Okay, so and here they are saying, what are all the CIDR blocks. So CIDR blocks, when they say what is that CIDR blocks, you have, this is the CIDR block. So now let us go to this particular IP address or the CIDR conversion, this particular table. I will just type the, see, look at this particular CIDR. For this particular CIDR, you have 65,536 IP addresses. So those many IP addresses you can have in your VPC. In your VPC, can have those many IP addresses. That is what it means. There are no IPv6 CIDR blocks. That is a normal behavior, and they don't have any tags associated. We don't need to worry about all these things. So this is the main VPC, and the VPC also has what they call as a route table. The route table means, what does route table means it will really say what are all the publicly available routes, for this particular table. That is what it is. Okay, so as an example, I am going here. What it says, what are all the routes? It says that, right? So routes, there are two line items you see. One is, it says that anytime somebody is really hitting this particular IP address 172.31.0.6, they can communicate locally within this VPC. That is what it has configured. If the source IP address is 172.31.0.0, so which means that anybody who is really coming outside of this particular any IP address that does not belongs to this IP range, if that communicates to this particular VPC, it will be blocked. Okay, then they have what they call 0.0.0.0.0/0, which means that any IP address across the globe, any public IP address, okay, if that comes, then in that case it really will hit what they call as an internet gateway. So this IGW is what it is an internet gateway. Okay, so this internet gateway is attached to default VPC. So this internet gateway will have certain way of allowing traffic. So I go into the internet gateway and see what is that internet gateway. This internet gateway is attached to say that it is attached to this particular VPC ID. So so which means that what does that mean? So this internet gateway is something that allows access of any network that is accessing your VPC from the external world. It can come and hit traffic on this particular VPC. So which means that if I am really opening a particular port on an internet, say I create a web server and I open port 80, or I really say, remember when we are when we are actually creating a server and it has an IP address, and you are trying to really access it from external computer, and you are passing the public IP address, then what happens is it is really allowing you to really access that particular host. So that, how is that allowed is this internet gateway only allows that particular access to really come and access their network. So this is something like the first layer of security for the AWS network itself. If this internet gateway is not there, then in that case your the access to your default gateway default network will not even exist. So let's talk about it when we really start doing some kind of a lab exercise. We can really start really looking into how that thing works. Okay. So these two things are something that we need to really talk about: a route table, what it does, and an internet gateway, what it does. Then it has what they call subnets. So there are 4 subnets available attached to this VPC. So subnet, like we said, subnet is something like, okay, I have this particular 65,536 IP addresses are there. So how are they segmenting it? So let's take this particular CIDR block. So this is what they have done actually when they are designing this. I am actually giving this IP address. See, look at this. There are 4,096 IP address only. Okay. So because 172.31.0.0, from there only up till 15.255 only they are allowing. Okay. So so that actually is a sub network. When we say subnet, my VPC is a broader network that can allow 65,536 IP addresses, but I am taking only a segment of it, 4,096. I am creating a subnet, and there is a reason why we are creating this subnet. I also told you, in the diagram that we previously created, right? So within a particular account, I can have multiple VPC and I can have multiple subnet. And this subnet, actually, we can really put something like, say, for example, a data layer has to be in a database server. It may be in a private subnet. App layer can be in private or public subnet. Web layer, it is almost always it is in a public subnet only. The same way, you also can have multiple departments. Each department will be using one subnet. This is how they segregate the network, so that, when servers are hosted in a network, they are actually placed on separate subnets, right? So that's how network is really managed. Networking is managed, and like we have seen, when people create network, since they don't want anybody external to the network access that network, these are private IP addresses created, and only local traffic is allowed. Any internet traffic cannot hit that network. They are very well securing private network like that. So, but at the same time, companies, if I am really going and really trying to access any kind of youtube.com or anything that they are going, I need to really access some video, means I need to really have that in a publicly available network. Then in that case, you will create the public network. So because of that, what we will do, network itself, I will segregate that there are whatever I want to secure, there are information that I don't want to share with the outside world. Then in that case, those will be private information. I will keep those information in private network, private part of my network. The internet, the information that I can share with the public, then in that case, I will go and really host that information in the public subnet. This is how people will design their IT infrastructure, to really say that how, if I am a company that that is involved in the business of selling books. Okay, so I have online books. Then in that case, a book need to be in the if I have an ebook, that ebook must be available in the web layer, because then only the public can actually, once they have access to that ebook, they will be able to really access it, right? In the application and database layer, what I will really have is, okay, there are people who are my regular subscribers and they have all their personally identifiable information. Nobody else should have access to it. Then in that case, I need to share their personally identifiable information in the private network. then it must be there. Credit card information or anything else, or somebody is really making a payment, then in that case, the payment related some information has to come and really hit here. And another thing, I will really have a lot of other things, because the thing is, all the transactions have really come, and I have some contracts that I have with all the publishers. Those contracts and all I need to store. Nobody else can access those contracts. Then in that case, I need to keep them in a private network, in a separate, I will create a separate subnet where I will really secure that information, and I will store that information. If I have, so all those things, the companies will need to do to really make sure that the information is segregated. So now let us try to do one thing. We will create our own VPC, and in that VPC we'll create some subnets, and then see that what happens. Okay, so I'm actually going here. What I'm going to do is I'm going and create a separate VPC, just for us, for our use. Okay, so let's say I will create a lab VPC. Okay, so for this lab VPC also, I'll try to create I can really go ahead and create, the same type of, because this is a separate VPC, it will really take a new set of IP addresses also. Okay, so I don't want any IP v6 CADR block. I don't want that. So tenancy, it says default and dedicated. I don't really want dedicated. I want default, because if it is going to be dedicated, then that's really going to be okay. So the name, the tag, one tag is already populated. I would like this particular tag to be set here, because dedicated tenancy, if you want, then it's going to ask you to pay for whatever IP addresses. I don't want to do that. So I'm actually always, we need to choose default, so that we are not really getting into a charging situation. So create VPC. Now this VPC is created. So this VPC comes with as you see, when this particular VPC is initially created, I go to my route table, look at my routes. So only a local route will be available by default. There won't be anything. Okay. So now I go to the subnet. Okay. So these are all the subnets that are actually tagged to the default VPC. What I am going to do is, just for the purpose of making this particular exercise interesting, I am going to go and create a subnet under this lab VPC. So 10.0.0.0.16, right? So what I am going to do, I'm going to segment this in a way, the same way it was done in the other this thing. So what I will do is my lab, sorry, I would say I'll create maybe a public subnet. Public subnet, I don't want those many. So I would say public subnet, I'll say 1, right? So subnets typically are associated with one availability zone, because in a particular region you will have multiple availability zone. So I am just going to associate this subnet to 2A, 2A availability zone. Okay, that is where I will place this subnet. Now I need to create a kind of a subnet IP CADR block. So I will again go for 24 only. So what I will do is, I will go and create a CADR block that will give me. So let me go here. I don't want really say if I go for 20, I'm getting this much. So I'll probably go for 24. 24 gives me 256 addresses. I'm okay, because right now 31.0.02, 31.0.255 it is giving. So here also, what I will do is I will just have 10.0.0 only 24. So this is what is the CADR that I will choose. So if you really look at that same thing, instead of this, I will just go and select only this. Then in that case, your IP range is 10.0.0 to 10.0.0.255. Okay, so I am actually only creating the IP CADR block, because this is a public subnet, and anyway it's a lab environment. I don't want to take a lot of the IP addresses. So already, the name and other things are there. So I am creating one subnet like this. Okay.
So if you give 24, the first three thing is constant, right?
Now, first
That's
three
what.
things.
Okay.
Yes, exactly.
Okay.
Yeah, because first 24 bytes or 24 bits are constant. That is what that 24 mask says. Okay, it is basically masking the first 24 bits.
Mhm.
Okay, masking means that doesn't change. The remaining 8 bits can change. That is why you are getting 256 combination. Okay. Now, what we will do is we will actually create a second subnet. Okay. So
Mhm.
I again take the same lab VPC, and this time I am actually going to create a what am I going to create is I will create a private sorry uh, public subnet 02. So here I'll take this, and this time I will use 10.0.1.0 okay. So this is again, it will give another 256 IP addresses. I think we can go and check, validate here. Like I said, 1.0.24, it will show you 1.0 to 1.255. So you can now go, I think the tags are in place, and create another subnet. So now I have public subnet 2 is available. What happened? Oh, okay. One minute. Okay. Subnet 01, subnet 02. Both are available. Okay, fine. All right. Both are in the lab VPC only. Okay.
Okay.
So inside the VPC only, I created the public subnets. I will also create a couple of private subnets, and we will use them later. But as of now, I will go and create a private subnet. I'm going to create my private subnet. In a, let's see. I mean, so I'm going into the VPC. I want to give my private subnet. So I will say private subnet 01. So here, this subnet I will actually try to put it in another availability zone, and then IPv4.CIDR block. Okay. So what I am doing is here I will probably choose 10 dot 10.15.0.20. I will just try to get 4096 blocks this time. Okay. And before creating it, I just want to make sure that my, when I say 20, what am I getting? So 15.0. So 20 means, okay, not 24, 20. Okay. So 20 means, then what does it mean? So from 15.255 means first IP it is giving 10.0.0.0. There may be an IP conflict. So I don't want to do that. I will probably try to go 31.0. So 10.0.16.0, because we have already taken some IP addresses 10.0.0.0 and 10.0.1.0 we have taken. So if I create a subnet with 10.0.15.0, then it probably will will say that there is some kind of an IP conflict, which I don't want. So I have to really say 10.16 to 10.31, that IP address I will take. Okay. So I will just say, see, if I really say, let me say if it allows me to create subnet, it says, see, there is a overlap is there, right? So it doesn't allow. Okay. So I have to put 31.0. Okay. So if I put this, now this, it will accept. So now I have 3 subnets, right? So a private subnet is also there. Now I will create another subnet. I think we will use all these subnets, but right now, I'm just trying to, you know, you can just follow along, and I think that you can. So now 10.0. what I would say 47.0/24. Okay. So again, not 24, 20. Okay. Again, this is something I'm trying to create for from 31 to or from 32 to 47. So you should be able to see 10.0.32 to 47.255. You will get it. So now I will go here. So as you see, 10.47.20 is there. So now I go and create the subnet. The subnet is also created. Okay. So now let's try to do something. What I am going to do is I want to create, since we have these subnets, what I am going to do is I want to create an EC2 instance in one of the public subnets and try to access that server. Let us try to see, how we can make it happen. Okay. So I'm going here. I go to EC2. So there are no EC2s that I have. So I'm going to launch an instance now. So I will pick a free tier instance and I go here. So I am going to use the lab VPC now. And see, here is one interesting thing that you see. This is a kind of a brand new subnet. No IP address we have allocated so far. Public IP.
Yeah, the default thing.
256 instances, but it only says 251 IP addresses available, right?
Yeah.
So there are totally 256 IP addresses, but there are only 251. It shows. Similarly, if we choose a private subnet, you see it says 4091 IP addresses available. So here also 5 addresses less. Okay.
Mm-hmm.
So I think I will not really ask the question why it is. There is a what's that? There is there is a reason for that. See what AWS does is it reserves 5 IP addresses. Okay. So 10.0.0.0, it is actually a kind of a network, or there is some certain specific concept that is available. So the last address 255, that is all the time that is getting used for broadcast. Okay, and AWS reserves the remaining first 4 addresses for its own purpose. I'll just maybe quickly look at AWS reserved IP addresses. What are those IP addresses? So so there are totally 5 IP addresses. First 4 IP addresses it reserves, and then the last IP addresses also it reserves. So it will really have all the description on what those are. So let's actually.
This is first and last 4.
First 4 and last 1. Okay.
Oh.
So it will have some description for that. Maybe this is a very, very long thing. Maybe in the forums, some of the forums, we can really find out like what exactly it is used for. Okay. So this is what it is. So 10.0.0.1, 2, 3. These 3 are so 0.0 is the network address. This is the network address. 255 is the network broadcast address, because this network address means for any other network, it has to communicate with that particular CIDR block. It will really use this particular network address to communicate. You cannot reserve this particular thing and allocate to a server. It's not possible. Then for VPC routing purposes, you will put it will again choose the 0.1. 0.2 will be reserved by AWS, for the DNS purposes. DNS is domain names resolution service. We'll get to that, what it means. DNS means, say for example, this is all IP address. These are all IP addresses, right? But we are actually typing a kind of a name that is something human readable, forum.aws.amazon.com. So this particular address will need to be translated into an IP address. The translation is done by the DNS. Okay, so the DNS is a kind of a domain name resolution service that actually takes this particular domain name and resolves that domain name into an IP address. So that is a kind of a special software that does it. So it needs a kind of a reservation in every network. And there is one IP address AWS reserves it for future use. They have not if there is for future use, they need something, they don't want to, then they all of a sudden they think that there is something that they need to do to improve their network performance. um, then they want one IP address, they want to reserve it so that for future use they can use it, right? That's what it is.
Okay. Okay.
So that this 5 address in every thing they will use it. See, now there is another thing that we have to do: auto assigning public IP. This is very very important because this is a public subnet. So we have this particular auto assigning of public address is currently disabled, but we have to enable it. That is very important. So how do we do that? So we probably may need to go for we can say enable, but use subnet setting is there. I would rather than putting it here, I would rather go to that subnet and then enable that particular setting. That is what I would prefer. So what I will do, without creating this instance, I will go to this VPC. I am going to look at the subnet. I'm going to look at the public subnet. And where is it? It is here. This is the public subnet. So let's see where that setting is to assign this is the resource share network ACL. It okay, auto assign. Okay, I think there is another way to do it. What we need to do is actions, modify auto assign IP settings. So enable auto assign public IPv4 address. So I am going to enable this for both the public subnets. So now I did it for both the public address, that the auto assigning of public address is enabled, so that I can create a server with public IP address. If I don't have the public IP address, then I think that I cannot use the server with the public as an internet or web facing server. So I'm coming here now. I am again choosing the lab VPC. I'm going to use the public subnet 1, and right now the subnet setting is enabled. So I'm going to use the subnet setting. There is nothing else I want to change at this time, because the subnet anyway means that it goes to that appropriate availability zone. Everything else I'm going to keep it as it is. I will just have the root storage. I always would like to give some kind of a name to the server. So I would really say that my test server, something like that. And I'll just have port 22. Okay, then launch it. I don't have a key pair right now, so I need to create a new key pair. And because this is a new VPC, maybe it doesn't have a key pair. So I would say my new key pair. I just would my new key pair. Okay, 6th February, because if I have to really do anything else, just for the show in Finder. Okay. Okay, so I have this key pair, and I will go to open another Finder window. Okay. Anyway, just to make sure I copy this. I'll go to edit, copy this item. I think I'm just going to save it in my directory. So I go here. I'm going to copy this. So I have this here. So I can go and connect, from my terminal. Am I in the right place? I'm not. So I'm just going to terminate this. First thing is I'm going to launch the instance anyway. Let me complete launching the instance. So, okay. Now I will come back and from here, okay, I cannot do this. Services, so I am under the new terminal now. So I do have this particular PEM file. This is there. So I'm going to do an SSH into this. So let's see this particular instance. So this instance is running right now. So I'm going here and checking where is my public IPv4. Okay, here is the public IP address. So I'm copying this public IP address and seeing at oh, okay, sorry. I think okay. So it's now not connecting. So there is something that is blocking the traffic to go through. Okay. So I'm not sure. Okay. So something that is blocking the traffic to go through, right? See, if you remember, we were doing something. We initially looked at our default VPC. In the default VPC, when we went to default VPC, what happened is in the default VPC, we went and saw certain things. We saw something called route table. So in this route table, we saw that the route table had some routes, and these routes we had something called internet gateway. Correct. So we have to really have an internet gateway that allows traffic to flow, from internet, to our public subnet. Okay. Otherwise, it won't. So currently, this internet gateway is attached only to the default VPC. So now we need an internet gateway that. So I would really say that this is lab internet gateway. Okay, so this is my lab internet gateway, and I'm going to create this. So an internet gateway gets created. So I have a internet gateway, but as you see, this particular internet gateway it is attached to this VPC. Now I need to take this internet gateway and attach it to do an attach for this. So I'm just going to go and attach it to VPC. I'm going to attach to this VPC. So I attached it.
Okay.
Right. So now, does it now allow me again? So right now I created that, but I still need to really make sure that I am actually attaching. It still will not. Okay, I attach to the VPC. Now the traffic happens. Now also the traffic does not happen. Okay, so I probably may need to go and really do something. That is where I'm just going to see that. Okay, I have a route table that is created for this particular VPC. Okay, so I'm going to go and really try to see that. Okay, is there a edit I do, or I probably maybe rather than using the standard route table, I can create a new route table. Okay, so let me see. Lab route table. I attach it to lab VPC and create it. Okay, so I have a new route table now, but this is not a main route table, right? So now for this route table, I also wanted to see what are the routes here. So we have only this route is there. So I'm editing route, I'm just going to add a route. So in this route, what I'm going to do, I'm just going to select this, and what are the targets that I will have. So the target I can really give internet gateway. So this is my lab internet gateway, and save routes. So what I'm seeing is any route that is coming in, it really goes and hits this internet gateway is one route that I'm creating. Um, I am going to now, what I'm going to do is probably I need to go to the subnet, because I really need to really attach the subnet. Even though I have created that particular route, and in that route I created this internet gateway. Let's see that if it really solves the problem. If not, I need to really see why. Okay, this still doesn't solve the problem. Okay. Okay, so let's see, like from a subnet level, whether I have to do any routing, from a subnet level. So we have to see, this is the public subnet. So in this subnet, how the uh, routing is there. So let us see. So here, what is the route table that is associated? Because there is a route table associated with this public uh, uh, with this thing. So it is attached to the VPC, but the route table is different here. This route table is probably the default route table. So I need to see that, how do I attach or associate this route table, edit routes, right? So okay, so no, I am not really going to take this thing. So whatever is the route table association that you have, this route table is there. So let's take this. Okay, I think what I will do is I will go to this route table and take this lab route table and edit subnet associations. Okay, so I will see this and take this particular subnet. What are the subnets that I have?
These are the default
01 and
subnet.
subnet 02, right? So I am taking this route and I am trying to route it to both these subnets, so that I don't really need to create another route table. So let's see, this is the lab route table, and this is associated with the two subnets, right? So this means that, okay, it is really going to use the internet gateway to allow the traffic. So what are the routes I have? 0.0 and anything that goes to internet network, and it is really associated with these two subnets, and any internet gateway traffic it comes, it allows that. So let's see that if that gives us the ability. See now, progress.
Okay.
Done.
Mm-hmm. Okay.
Okay, I think now I have a permission issue. I think these are standard this thing only. So now I logged in, right? So
Yeah.
now see what we have done right now. We created a new network. In that network, we created subnets. In that subnets, we created EC2 instance. And now we logged into that particular EC2 instance. Now I can also check whether I can perform the other things, because that yum update is basically is going to make this server as a web server. So let's see like whether it is really able to run. It is going checking. So currently probably there are no packages marked for update. Maybe this particular server I am still able to access from internet. Let me go and check whether I am able to access this server from internet. So maybe am I able to really hit the test page? I can really also say that, see that. So now this is the instance and I have some packages installed. So let me go and check if I have any or I don't know whether I need to do more or anything like that. Oh, okay. I don't think that I have allowed anything like an access, what is that, the route 80 or anything like that. So I probably may need to create, that particular, allow that particular routing. So I'm just going to go to the security details, and if I can add any inbound rules, okay, it doesn't allow me to add here. So if I associate a security group, so security group is here. So this is the security group. So in this security group, let me add maybe the HTTP traffic. Let's see. Yeah. So I will just give this and save rules. So this is the EC2 instance right now, and this instance. Okay, so right now I take this IP address and go here. Let's see. Page isn't working still. Okay. Maybe something else I need to do. I don't know what I need to do at this particular point. I will have to come back to it. Maybe I need to refer why this is still not, having a, maybe it doesn't have a kind of a public IPv4 DNS. Why it is not really having is something I need to research that. But this is an example that, we are able to create a server in a subnet, and we actually, how AWS created a default subnet, we have really tried to, create some parts of, that networking configuration that we have done. Okay. So now typically what we can do, maybe in the next class, what we can do is we can actually try to create a server in the private network also, and try to see that, if we can do that kind of a, okay, I will really have a kind of a web server, and that particular server have some kind of a page, and there is another server in the backend, and how we can communicate. Let us try something. I will also really try some kind of a lab that connects to the front end and then goes to the back end. So the another part of this that I am going to do is, I would like you to spend some time, because we have really done some basic basic thing. See, the very, very basic AWS certification anybody can do is AWS Cloud Practitioner Essentials. Okay. So what you can do, there is a course that is available, within AWS itself. Okay. This particular course is a completely free course, for this. So you can go to AWS website, right? So in the AWS website, go to learn, and then AWS certification. If you go to AWS certification, they have this thing called prepare for an exam. So go here, and a lot of certification comes. The foundational level AWS certification is Cloud Practitioner. Okay. So this Cloud Practitioner, let us click on this Cloud Practitioner. So for this Cloud Practitioner, preparing for exam. Okay. So let's say, how am I going to prepare for exam for this? Okay. I think again it comes here only. Okay. So explore relevant AWS training. So for this, we have multiple trainings are there. So Cloud Practitioner Essentials, this is the training. You take here, they have a kind of a digital course. So you go and click there, there is a digital course material that will come in. It will ask you to sign in. Normally, if you have an Amazon account, not AWS, wherever you buy your things, right? So you can use that account itself. Okay.
Okay.
Just log into that account. Then you should be able to just use that login. Then you should be able to go here. Then actually, there is a course, and just click on it. They will have, self-study materials. Okay. So I go and launch this course now. There are self-study materials available. So you can just go and really try to, read some, there are many chapters, but one of the things sometimes if you don't really have some of the knowledge of other things, if you go and really watch these videos, many things we may not understand. So that is why so far I didn't really talk about this particular course at all, this particular
Okay.
pre-course at all. But right now, whatever you have gone through, you will be able to go and really start reading this, and you may be able to really make some sense out of it. So
Okay.
I'll try to really take, this particular module 1, of their book. I'll just go through that with you. So, um, so this particular module, let us take a peek at it. So in this module, what they are going to really do is they will actually tell you, how to, summarize the benefits of AWS, how you are going to describe the differences between, the on-demand delivery and cloud deployments. They will say how cloud is a kind of a pay-as-you-go model.
Mhm.
Video is one, and I think that in the video they will cover so many things, so we don't need to really talk about everything. So in short, what they are trying to do say is AWS offers a massive range of services for every business. So which means that it will starting from the basic elements, the compute, storage, network security. So we have already seen compute, storage, but there are many things, network security tools, then blockchain, machine learning, artificial intelligence, and all advanced services. So they have everything. So way more than we have time to cover in a foundational class like this one. So let us simplify. So from foundational cloud compute model, so they actually try to really take a kind of a coffee shop example. In a coffee shop, you probably may have a number of clerks who are serving, or they what they call as a barista. So the number of baristas that are there in the coffee shop, depending on the crowd, they cannot do that. It is something like you have to, if you have a kind of a clerk who is really going to come for say 4 hours or 5 hours, whatever number of hours that they are going to be servicing, those many number of hours they have to be paid certain dollar amount. If the crowd reduces during off peak hours, then in that case they have to really say that, okay, I don't want 5 clerks, but probably I may want only 2 clerks. They cannot very easily do that. But some of the retail companies, they do that, in US also. When there is a peak season, they hire more store associates. When it is off peak, they cut down the store associates. All those things they do, correct? So similar to that, here AWS, what they are trying to do is compute means only when a particular instance is running, you are getting charged. That is where, I also told you, as soon as you don't use it, you are actually going to terminate that particular server, correct? That's what
Yeah.
it is. You can go through the video. The video probably, um, I think in an on-premises data center, what you will do, say, I think let's watch the video also.
I'm Blaine Sunner, AWS Training and Certification. I've been teaching technology for more years than I'm willing to admit. After spending time teaching the newspaper industry, I moved to AWS, where I've taught classes globally on many different disciplines, such as security, cloud architecture, DevOps, big data, AI and ML, and theater history. My mama was a teacher. My daddy was a teacher. My grandpa was a bartender. I was born for this.
Hi, I'm Morgan Willis, a senior cloud technologist at AWS. I started in the IT world about 10 years ago, and along the way, I decided that I was missing something. I missed the helping and teaching aspect of IT that I had in my first job in IT support. So I went into teaching software development in different areas around the US, and then I eventually landed here at AWS, where as a cloud technologist, I get to support others in their cloud journey every day.
And I'm Rudy Chetty. I come from sunny Cape Town, South Africa, home of Biltong, Boerewors, and Bunny Chow. I'm a solutions architect and have been with AWS for over 3 years. Teaching is my passion, and I can't wait for you to dive into the course and learn. Ngiyabonga Gakulu, feels geluk, thanks a lot, and good luck. Solutions like blockchain, machine learning, or artificial intelligence, and robot development platforms, all the way through very specialized tool sets like video production management systems and orbital satellites you can rent by the minute.
All that, however, is way more than we have time to cover in a foundational class like this one. So let's simplify the conversation by starting with the fundamental cloud compute model.
Almost all modern computing centers around a basic client-server model. Now, I know it can be more complicated than that, so let's take a look at our coffee shop.
This coffee shop is going to give us some real-world metaphors to help you understand why AWS can change the way your IT operates.
Let's make Morgan the server, the barista, and I am the client, the customer. I make a request. In this case, it is for coffee. Now, in the computing world, the request could be anything. It could be rain pattern analysis in South Africa, or the latest x-rays of your knee, or videos of kittens. Whatever is the business, basically, a customer makes a request, and with permissions, the server responds to that request. All I want is a caffeinated beverage. Morgan represents the server part of the client-server model. In AWS, she would be called an Amazon Elastic Compute Cloud, or EC2, an EC2 instance, a virtual server. So from an architectural point of view, the transaction we did is really simple to explain. I, the user, made a request to Morgan, the server. Morgan validated that the request was legitimate. In this case, did I give her money? Then she returned a response, which in this case is a berry blaster with extra caramel shots.
Now, in the real world, applications can get more complicated than just a single transaction with a single server. In a business solution that is more mature, it can get beautifully complex.
To avoid this complexity, we're going to start simple. We will build this discussion out so it is easy for anyone to understand how these concepts build on each other. So by the end, those complex concepts, they'll be easy to understand. Let's start with a key concept to AWS, and that is you only pay for what you use.
This principle makes sense when you run a coffee shop. Employees are only paid when they're in the store working. If Rudy or Morgan are off the clock, well, then they don't get paid. The store owner simply decides how many baristas are needed and then just pays for the hours they work. For example, the coffee shop is about to release a new drink, the Pumpkin Monster Spice. In anticipation of this launch, you could always staff your shop with a dozen baristas all day long, just in case you suddenly get an unexpected rush at some point in the day. Only, let's be honest, for most of your day, you don't have near enough customers to justify paying for all those employees.
And yet, this is exactly what happens in an on-premises data center. You can't just snap your fingers and triple your capacity. At AWS, you don't prepay for anything, and you don't have to worry about capacity constraints.
When you need instances or baristas, you just click a button and you have them. Then when you don't need them, another click, and they go away, and you stop paying for them. The same way you don't pay for employees for hours that they're not working.
So pay for what you need becomes the first key value of many for running your business on AWS. And that is really why we're here, to help you understand how AWS is built to help you run your business better.
We hope you stick around for the entire course as we dive deeper into these concepts and help launch you on your journey towards being a cloud practitioner.
So this is what the key thing, when we prepare for exam, this is what is important, because they will really say you don't prepay for anything. It is pay as you go. It is not like on-premises data center. So those are the keywords that we need to keep in our mind, right?
Okay. Yeah.
Okay. So when it is important that you read that, you watch that video. But right now, after we have gone through all these things, how we are really paying for, how the payment works. We have seen some free tier limit, 752 hours of EC2 instance is free. So that is why, at the beginning of the month, we, turn on the server, and then we actually turn off the, beginning of the session, create the server, and at the end of the session, we terminate, so that, we don't really pay for it. We can use that limit within that, right?
Yeah.
That's what we have seen, correct? So, so that's basically it. I think I can also show you something, to really make this particular, to make a kind of a real connection to it. So I am going here. See, basically what they have something called Cost Explorer. Okay. So I go into this Cost Explorer. This is my account. Okay. So see, right now there is no cost for my current month, right? So I think it also have, it doesn't have anything like a month-end cost or anything like that. So it will also have some reports that says that what are the monthly costs by service. Okay. So as an example, it says in January 2021, there is something that happened with EC2 instances. There is a $3.89 cost. And also, maybe another service, there is some cost. None of the months, there was some cost. So if I select this, January 2021, or let me see why it's not showing. Okay. So January 2021 is there. So if if I have to really break it down also, I will be able to break it down. I'm just trying to see like, okay, let me see, instead of last 6 months, I will just put, I'll just give a kind of a range itself. So I will say 01, 2021. So I'm just taking this particular month only. So it says EC2, correct? The service is there. So service total is there, this much. It will have something called running hours. So I'm just trying to see where running hours it will say. Okay, so let me look at another report. Okay, monthly EC2 running hours, costs and usage. So if I go here and look at this particular month, say in January, I am supposed to have 750 hours of my free tier, but I ran 1085 hours. You know what happened? There was one particular session, I forgot to shut down a couple of servers.
Oh, that's
and so $3.89 gone.
Okay.
Okay. So that's what happens, right? So I think that's what, we need to understand that, anything that we do, I think I can go back to this. Oh, okay. Resume the training and launch course. Okay. So now I'm going back to the course. So we have seen the module 1. So I'm not going to go to the module 1. Let us finish up this particular module and take some questions also. Then, see, rather than seeing the video, I will really just walk through some of the things here. You can actually watch the video. Then I think that, when the video also will really go for some time. So you have cloud-based. See, there are 3 types of deployments that is what they are talking about here. Deployment models for cloud computing. So when in a company, what happens is they are talking about 3 different types of deployment. One is cloud-based deployment. Another is on-premise deployment. Another is hybrid deployment. So a company can really do 3 things. One is all parts of the application runs only in the cloud, in the public cloud. So then migrate existing applications to the cloud, design and build new applications in the cloud. So cloud-based deployment model means migrate all the existing applications to the cloud, or you can design and build new applications in the cloud. So which means that I really do not really look at anything. Everything is created as a virtual server here. So company might create an application consisting of virtual servers, databases, everything. On-premises deployment is what they call it as. On-premise means you buy everything. You deploy resources by using virtualization, resource management tool on your premises. You don't really have anything cloud, but your on-premises, you can use it as a private cloud deployment. So this model, resources are deployed on premises. They will use virtualization, resource management tools and all, right? Hybrid deployment means you use both on premises and public cloud. both of them, cloud-based resources. See, what they do is today they call anything like AWS, Azure, they call that as public cloud. In on-premises, if you have virtualization infrastructure, that is private cloud. If you don't have any virtualization, you don't really do anything, then there is no, it is something like pure on-prem. So there are multiple classifications are there. But as of now, you say that anything cloud-based means it is from a public cloud. Anything on-prem means it's a private cloud. Okay. For the purpose of exam, you can keep it that way. Okay.
Okay.
And these are some benefits of cloud computing, they say. One of the things, it is something like trade upfront expense for variable expense. Upfront expense means data centers, physical servers, other resources that you need to invest before using them. So which means if I have a data center, if a company has a data center, they have to buy physical servers. We all studied initially, and other resources that where we need to invest before we use them. Variable expense means you only pay for computing resources you consume instead of doing this. So what cloud gives you, I only pay for what I consume. That is what cloud gives me. Okay.
Okay.
So that is one benefit. Then the next thing is stop spending money to run and maintain data centers. This is another one. Computing in data center means, you need to spend money, time managing infrastructure and servers, right?
Yeah, got it.
Then stop guessing capacity. So I don't need to really guess anything like capacity or anything. We launch EC2 instance when needed, pay for the compute time only we use. So we don't need to really do a lot of science work about, what is my capacity. We may need to do, but we don't need to guess way too much, right?
Yeah.
Then
True.
massive economies of scale. That is what they said. I can really use one server, or I can use 10 servers, 100 servers, pay as you go. When I don't need the servers, I can destroy them simply. Okay. Then increase speed and agility. The flexibility of the cloud computing means it makes it easier for you to develop and deploy applications. So the flexibility means that more time to experiment and innovate. So that is what it is. So the increasing speed, is I don't need to spend time really deploying infrastructure. I straight away go ahead and deploy something in minutes, and then I can start developing applications. Correct? That's what it is. They also say go global in minutes, because if I develop an application here, I can really try to take this application, deploy it across the world. I don't need to go and buy, a land or infrastructure in another country. I can just simply launch it.
Yeah, everything in public.
Yes, that's it.
Mm-hmm.
That's what, cloud offers. That's what they say. Okay.
Okay.
So now we have seen this. Let us actually try to, go and take a little short quiz. So you can try this. What is cloud computing? So there are 4 responses here. Backing up files.
Backing up files, stored on desktop and yeah, just I'm reading.
Okay, you can read.
Okay. Right. Deploying application connected to on-premises, running code without a need to manage or provision service. Delivery of IT resource application to the internet. Pay as you go. Pricing. Running code without needing to manage or provision servers. On demand and
yeah. See, first let us eliminate things. Can this be the answer? Backing up files that are stored on desktop and mobile devices for cloud computing, because we studied some material about this. So cloud computing, can this be the answer? Yes or no?
No.
No, correct. We can eliminate this. Deploying application connected to on-premises infrastructure.
No.
No, correct. Running code without needing to manage or provision servers.
Running code without, I don't get this meaning.
Okay. They say that I don't need to manage server or provision server, but I can run code. Okay.
Okay. So on-demand
delivery of IT resources and application to the internet with pay-as-you-go pricing.
Pay-as-you-go pricing. Yeah, with pay-as-you-go pricing.
Correct. So that is the keyword, right? That is what we learned some time back.
Yeah, pay-as-you-go.
Correct. So this is the thing. Okay.
Yeah.
So this is the correct answer.
Mm-hmm.
Okay? So now let us go. What is the another name for on-premises deployment? Sometime back we watched that particular thing. correct?
Yeah. On premises. Yeah.
Private cloud
On
deployment, cloud-based application, hybrid deployment, AWS cloud.
on premises deployment. Private means everything in a private.
Yes.
Cloud based hybrid means both private and public
Hmm.
involved in it.
Correct.
Hmm. So AWS cloud means related to cloud based application, right?
Correct. Correct. So
Okay.
they are talking about on-premises.
On
So we'll
premises.
start eliminating again. So AWS
So
cloud.
AWS cloud.
No. AWS cloud is it on-premises?
So the answer is AWS cloud, right? On premises.
No. See, on-premises means you own that. On-premises is always owned by me. Correct. When I go to AWS means I don't want to own any on-premises. That is why I go to AWS or public cloud. Correct.
Sorry, on premises means?
On-premises means maybe we can what we can do is we will really go back and then try to read the previous thing. See, in this chapter we studied some cloud-based deployment, on-premises deployment, hybrid deployment. So cloud-based deployment is the one where you migrate applications to the cloud. AWS is cloud. That is why we are saying that AWS, right? So it's something
Okay,
like,
okay. Yeah, okay. Got it.
okay, on-premises
Okay.
means you are really trying to really do, and here we are talking about, this is where we said private cloud
Okay,
deployment.
private. Okay.
Okay, so
Okay.
so that is where it's this is the going into the theory part of the things, right? So we are
Okay.
saying this one we have already chosen. So what is the another name of for on-premises deployment here?
Private cloud deployment.
Yeah, we just saw that, right?
Yeah, I forgot the name on premises when you go through
Yeah,
that
I
subject.
think that is where we need to start.
Yeah.
You can just go here and start reading. It is the thing is
Because
I found it very difficult.
because all the terms are new to me, right? So suddenly the words are not sparking on my mind.
Correct. What does the scale of cloud computing help you to save costs? You do not have to invest in technology resources before using them. The aggregated cloud usage from a large number of customers results in lower pay as you go prices. Accessing services on demand helps to prevent excess or limited capacity. You can quickly deploy applications to customer and provide them with low latency. So there are four things that they have said. Scale of cloud computing. Here we have to always look at keywords. How does the scale of cloud computing help you to save costs? They are talking about two things, right? Cost is one thing that they are saying. Second is scale of cloud computing they are saying. Correct?
Yeah. The
So
aggregated, the second one.
second one, that is what is I am thinking. I am just trying to rule out because I am thinking that accessing services on demand helps to prevent excess or limited capacity is something that they are saying, but it doesn't sound very convincing to me. You can deploy application to customer, provide them, because when they are talking about latency and scale doesn't have anything to do with that. It is not probably the right answer. This is probably the right answer, but let us see.
Okay.
Yeah, that is the correct answer.
Yeah, correct.
Yeah, because not having to invest in technology, because trade upfront expense for variable expense, that's a different thing. Okay, accessing services on demand is stop guessing capacity. So that's a different terminology altogether. Okay, so the for third one is go global in minutes. If you go global in minutes, then probably the quick deploying of applications will come. So every keyword is associated with something. So that is where we have to really look at the keywords and guesses.
Keywords.
So all those things need to be there. The main reason why we went through all these lab exercises, now when we read this, we also can really make a lot of sense. It's easy to remember when you see some practical views also, correct?
Yeah,
So
true.
now you can go to this particular website. Maybe what I will do before we close this, you can share your screen and then I will walk you through on what are the steps that you can follow. Okay.
Okay. Can I do that tomorrow, Mama?
Oh, cherry. Okay. All right. Okay, then bye.
Okay, thank you.